JavaScript closures are functions that can access values outside of their own curly braces. In order to call a function in your code, the JavaScript interpreter needs to know about the function itself and any other data from the surrounding environment that it depends on. Everything needs to be neatly closed up into a box before it can be fed into the machine. Take, for example, a pure function that only depends on its own arguments and internal data. What we have here is a fully self-contained closed expression. When it's called, it gets pushed onto the call stack, where it's executed and its internal data is only kept in memory until it's popped back off the call stack. But what if that function references data outside of its own scope, like from the global environment or an outer function? That leaves us with an open expression that references other free variables throughout the environment. Now, in order for the interpreter to call this function and also know the value of these free variables, it creates a closure to store them in a place in memory where they can be accessed later. That area of memory is called the heap, and unlike the call stack, which is short-lived, it can keep data in memory indefinitely, then decide when to get rid of it later with the garbage collector. So a closure is not just a function, it's a function combined with its outer state or lexical environment. As you might imagine, closures require more memory and processing power than a pure function, but you'll come across many practical reasons to use them. The most important one being data encapsulation, to prevent leaking or exposing data where it's not needed. We can create a closure by defining an outer function that contains the state, then an inner function that operates on it. The data contained here will not leak out to the surrounding environment. The inner function has access to data defined in the outer function scope, but the outer function does not have access to the inner function. In addition, many JavaScript APIs are callback-based. You can use closures to create a function factory that takes an argument, then returns a brand new function, which can then be passed along to other functions that expect a callback. This has been JavaScript closures in 100 seconds. But stay tuned, because today we're going beyond 100 seconds to take a look at one of the most famous JavaScript trick questions that will wreck you on an interview if you don't know closures. But first, make sure to like and subscribe. I'm trying to fulfill my childhood dream of getting to 1 million subscribers, but it's going to be really hard to get there if you don't click the button. Just kidding, I have a ton of fun making these videos and learn something new every time. A great example of which is this tricky JavaScript interview question. The question itself is, what does this code log out? Let's go through it line by line. First, we're declaring a variable I with the var keyword, then a for loop that will run 3 times by incrementing that variable. Now, inside the for loop is where closures come into play. We define a function, log, that console logs the global variable I. This is not a pure function because it depends on a variable outside of its scope, therefore creating a closure. Then from there, we set up a timeout and pass the log function as the callback. This queues up a task to execute the log function after 100 milliseconds. So what do you think the output of this code will be? We're capturing the I variable in the closure for each iteration of the loop. So it would seem like it should log out 0, 1, 2. But if we log it out, it actually console logs 3 times. To understand why that happens, we also need to understand the difference between var and let. When you use var in a for loop, that variable actually gets hoisted up into the parent scope, which in this case would be the global scope. Watch what happens when we change the variable to let. We get our original expectation of a console log of 0, 1, 2. With var, we have a global variable that we're mutating over and over again. But with let, we're creating a variable that is scoped to the for loop. In other words, it's local to the for loop and can't be accessed outside of it. Now remember, a closure is the combination of a function and its lexical environment. In the case of let, the closure is capturing the log function along with the variable I for each iteration of the loop, which would be 0, 1, 2. If we didn't have a closure here, JavaScript would allocate that I variable in memory in the call stack and then immediately release it. But because we do have a closure, it stores that variable in the heap memory, so it can be referenced again when that closure is called by the timeout in the future. But when var is used, it's capturing the reference to the global variable. The reason it logs 3 times is because the timeout doesn't run till 100 milliseconds later, long after that for loop has completed and iterated up to 3. We can actually examine this behavior in the browser DevTools by adding a debugger to the closure. If you try to run this code in the browser with the DevTools open, it will take you to the Sources tab and allow you to inspect the call stack and scope of the function. When let is used, you can see we have a block scoped variable named I. But when var is used, that variable is now in the global scope, which changes the way it's captured by the closure. That's a pretty tricky one, but JavaScript interviewers love to ask questions like this. If you ever find yourself faced with a question like this, the best thing you can do is talk through the code slowly and explain how a closure works so they know you're on the right track even if you don't come to the right conclusion. I'm going to go ahead and wrap things up there. Thanks for watching, and I will see you in the next one.